We've all heard the term data science, just like thrown around willy-nilly. Even as someone who works in what is generally called data science, as a data scientist, I still ask the question, what is data science? So first off, I'd like to say the term data science is relatively new. When I started working in this field, the term didn't even exist. Back in my day, we used to call this analytics. So we'll sometimes use the word analytics instead of data science simply out of habit, while acknowledging that there is a difference between a data scientist and a data analyst, where a data scientist is usually doing more advanced work than the data analyst, but that is separate from the field of analytics. Okay, now that we have that out of the way, let's talk about what data science is. So technically, by definition, it combines the fields of mathematics, computer science, statistics, and software engineering. But that is super vague and is not a helpful description for most people. So I'm going to break it down to a few concepts and give an example to walk through what data scientists actually do. So the work that a data scientist does can be broken down into 3 categories: descriptive, predictive, and prescriptive. I'm going to explain what each of those are by using an example of something that I am a huge fan of: burritos. Specifically, taquerias. So we're going to pretend that we have a taqueria, and we are going to explain how data science could be used at this taqueria with each of our 3 categories of analytics. Up first, descriptive data science. This is all about describing what's going on right now. At our taqueria, descriptive analysis would answer questions like, how many burritos are we actually selling? And can we break this down by day of the week to get some insights, like that we sell most of our burritos over the weekend and not many on Monday? Or can we break this down by hour of the day and see when our lunch and dinner rushes happen? Or we can look into seasonality and how the demand changes over the year, and we see that there is a huge demand spike in the summer and also around the holidays. So this is descriptive analytics. It's just observing the data that is happening right now. It's just describing, if you will, and nothing more. And we can, and we will, use these analyses to make some decisions, but those decisions will fall under either predictive or prescriptive analytics, usually. So descriptive data science is really just aggregating the data and analyzing it enough to tell us what's currently happening. Now, this might sound super basic, and at some level, it is pretty basic. But in my experience, most companies, even the largest tech companies that you think are the most advanced, they're still mastering describing their data. And that's not to say that every part of their business is focusing on the descriptive piece. Each small part of the business will be at a different stage. But many parts of many businesses are still working on descriptive analytics. And that's okay. It's expected. It's good. For our small little taqueria operation, describing things is straightforward. But at a large internet-based corporation, they have tons and tons of data that they've been collecting. I feel like if there were a way to weigh data, it would literally weigh tons. And this data, it's not always clean. Actually, let me rephrase that. It is never clean. And there's not always only one way to collect data or only one group working on collecting it. So there could be overlapping or duplicate data sources. So which one do you use? And then among the data that we do have, we probably have data tables with millions of entries and hundreds of columns or fields. And the names of those columns could be ambiguous. They were probably generated by one person who knew the data super well, but didn't name the columns in a way that would be easy for most other people to understand. Like, take our taqueria. Let's say we have a super duper burrito maker guy, and that is amazing, named Al Pastor, but his friends just call him Al. And let's say that Al was our guy that collected all the data on what burritos were made when and put the data into a data table. And he named a column PB. And to Al, that is obviously pinto beans. But to anybody else, that may not be so obvious. And then you have this column titled PB, and the super duper burrito maker left the taqueria to start his own place. And now we are left with this column titled PB, and nobody knows what it means. So who's going to figure it out? The data scientist. That's who. Now, this story about the super duper burrito maker might sound super absurd and far-fetched and made up. And okay, the burrito part is made up, but the rest of it, I assure you, is not. This is exactly how things work. Okay, So even when you establish what data you have and what it all means, then you can get to the actually descriptive part. And this part is condensing, aggregating, and analyzing the data to turn it into something that is valuable, and then present and display it in a way that's useful to actually answer questions that people have and give insights into what's going on. And once you have the descriptive piece done, you can leverage that to do your predictive data science. Predictive data science is going to answer important questions like, how many burritos are we going to sell of each type, at each location, on each day? And all of this is going to be based on our historical burrito sales, or our descriptive data science. Now, maybe arguably, maybe not, predictive analytics is probably the most popular type of data science because it includes fields like machine learning, and it arguably includes AI. I'm not going to go into AI on this video, but I will say that AI can mean a lot of things, and sometimes in certain fields to certain people, AI can mean creating predictions, which is why it can be included under the umbrella of predictive analytics, but I'm not going to go into any details on AI. Okay, so with predictive data science, I'd say that there are two main tool sets: machine learning and statistical prediction methods. Sometimes these are grouped into the same bucket, but often enough they are separate, and they are technically two separate approaches, so I'll talk about them separately, but they achieve the same end goal. Let's start by talking about statistical methods. Statistics is a field that covers a lot of ground, not just predictions, and includes things like distributions, like the normal distribution, or sampling methods. It's just a branch of mathematics that has been around since literally the 8th century, and statistics can lead us into some of our old school kind of bread and butter prediction methods like linear regression or clustering or even time series forecasting methods. Now, you don't need to know what any of those are, but the point being, these are all mathematically proven and mathematically driven methods that were created based on math, using correlation and historical data to say things like, in the past, when a burrito costs X dollars, we usually sell Y of them a day. Or, on Cinco de Mayo, we usually sell X% more burritos. And statistics uses mathematically proven methods to do this as best as we can. Then machine learning came along and basically was like, look, guys, we can make better predictions than statistical methods, but using these concepts that aren't quite mathematically proven. They just kind of work. Now, sidebar here, machine learning. Is the machine really learning? I mean, kind of. As more information is received, it makes better predictions. But statistical or old school prediction methods have this feature too. And machine learning doesn't mean that computers are thinking in the sense of like futuristic robots in movies. It just means that when it gets more information, it makes better decisions, which I guess actually is the definition of learning. So maybe. To understand what machine learning is, let's look at an example of a commonly used machine learning method, decision trees. You might think you don't know what a decision tree is, but you probably do. It's one of those flow charts that's like, if I eat this 4-day-old burrito, will I feel sick? Yes or no? That's a decision tree. In terms of using this to make predictions, we can take all the historical data and create a decision to answer a question like, if someone walks into the taqueria, what are the chances that they'll buy a burrito rather than something else on the menu? And then we can traverse the tree down to see what percentage of the time someone will buy a burrito with specific fillings in it. This is a decision tree, and we can use it to make a prediction for how many of each burrito type will be ordered on a given day. And then there's the machine learning method called random forest that goes one step further. As you can imagine, looking at a decision tree, the kind of rows of this tree or branches can be in any order, and the actual branches we have in there could also differ. In fact, there are a lot of different ways we could order these branches. Random forest will randomly create a forest of these trees and then follow them to the end, given your current situation, and then it's going to take the mean of the ending probabilities of each tree. As you can maybe imagine, it's hard to prove exactly how well this works mathematically in the way that you would with, say, linear regression, where you could say something like, we have a confidence interval of 95% that will be within 7% of the actual number, and the shoe someone is wearing is the best indicator of their meat choice by a factor of 2. So we don't always get that specificity that we do with statistical methods, but it works well, surprisingly well, and the more data we have, the better it works. So is the machine learning? I mean, I like to think of it as kind of creating this gut feeling. You know how sometimes you just know, like today we're going to sell a lot of burritos. And that could be because as a functioning, knowledgeable person, you know things like today is Saturday and it's Cinco de Mayo and the weather is beautiful. So from experience, you just kind of know. You have this gut feeling that today we're going to sell a lot. And what the machine, aka the computer, is trying to do is to gauge that same gut feeling by collecting all of this data and learning. Okay, so that's machine learning in a very small nutshell. And that is part of predictive data science. So, and maybe more importantly, what do we use predictive analytics for? Well, we want to predict things like how much effect does Cinco de Mayo have on our burrito sales? We can go back and look at how much sales increased historically on Cinco de Mayo and using some other factors get a prediction for how much we think the increase will be in future years. Or we can try to determine the impact of price on sales. If we sell our burritos at a discounted price, how much do our sales go up? Or we can predict how many pinto beans we'll need next week. All of these predictions are going to be based on historical data, meaning we look at what's happened in the past, any trends over time, and we try to create a forecast of what we think will happen in the future. So we need a decent amount of historical data, and that data has to be relevant to what we're trying to predict. Now, there's one piece of predictive analytics that I didn't mention, but I feel like I should, and that's working with unstructured data and natural language processing, or NLP. This is basically the root of what we now call generative AI, or Gen AI, what ChatGPT does. And I am not going to go into detail on this video, but basically, this is a slightly separate category of analytics that takes unstructured data, like text, so not numbers, and it finds patterns, enough to then create new patterns. So you know how, like when you're typing on your phone, and there's a suggestion for the next word, like if I type the word al pastor, the next suggestion could be burrito or taco. And that's because historically, those have commonly been the next word after al pastor. And that forms the basis for a lot of generative AI. When a question is asked, it starts forming the answer and doing like a next word prediction. All right, now moving on to our last, but definitely not least category, and that's prescriptive data science. Once we know what's currently happening and we have a prediction for what is going to happen, we can ask the question, what should we do about all of it? And how do we make these decisions? Well, a lot of the time, not all of the time, but a lot of the time, prescriptive analytics uses mathematical optimization. This is a whole field on its own, one that I could talk about for hours, but I won't. Basically, it formulates the question as a math problem with two parts, an objective and the constraints. The objective will specify what we're trying to optimize. This could be minimizing cost. It's almost always minimizing cost. Or maximizing throughput, or minimizing waste. But it's always minimizing or maximizing something. We want to find the best possible answer given our constraints, where our constraints are laying out the rules for how things work. These are things like we have to stay within budget, or we want to make sure we meet demand. And a lot of the time, these constraints are essentially replicating some real-world process in what is often called a digital twin, because we're replicating the real world in the digital world. And then we're trying to find the best possible solution in that digital world. Prescriptive data science will try to answer questions like, we want to open another branch, and we have a set of possible locations where we can open that branch. So what's the best location to open that branch if we want to minimize costs? We'll have to take into account labor costs and real estate costs and where we think we could have a lot of burrito buyers and cost of transporting ingredients to that location, all while making sure we meet demand and making sure everything fits within the confines of our physical taqueria. Like, we can't store 1 million pounds of pinto beans because we just don't have the space. And besides, pinto beans have a shelf life. That means that they would expire before we'd even use them up. So these are our constraints that define our realistic realm. This type of problem, where we choose a new location or we close an old location, is often called network design. Prescriptive analytics can also answer a question like, given a range of possible forecasts for pinto beans for the next week, how much should we actually order? We don't know exactly what the demand will be, but we definitely want to meet demand, and we also want to minimize waste, so we can find that optimal ordering amount within this range. Or we can use historical data around peak ordering times to predict when orders will be placed and prepare for orders in a smart way. Let's say we would keep running into a problem where the guacamole tray is empty, but we want to optimize when it's made so it doesn't turn that gross brown color before it's all used up. So we want to determine the best times to make guacamole. This type of problem is often called production scheduling, where we figure out when to schedule production. Okay, so that's prescriptive data science, where we try to answer questions around what we should do and how or when to do something. And there you have it. That is data science, broken down into its three main parts: descriptive, predictive, and prescriptive. In practice, most companies are working on doing all three, but a good chunk of work is still in a descriptive phase. And like I said at the beginning, that might sound crazy, but the descriptive phase is hard and it's necessary to do any predicting or prescribing, but it's not an easy phase. And once the descriptive phase is nailed down, the other pieces fall into place a lot easier. And maybe this goes without saying, but just in case it doesn't, I'll say it. Using data science and analytics to look at your data and make better data-driven decisions can save you a ton of money. A ton. It works. And that is data science.